Okay, everybody can see now? Okay, so this is section 8.3. The first day we talked about this, section 8.1, just kind of introduced us to sequences and series. We talked about recursive, which is that silly one that you have to have the term before it in order to find the next one. We talked about just identifying sequences, finding terms by just plugging in, that sort of a thing. Then yesterday we talked about arithmetic or arithmetic. And the thing with arithmetic or arithmetic, however you want to say it, you found the common difference. The common difference is kind of like the slope. It's when you add or subtract the same thing every time. You guys remember that? We found partial sums, that sort of a thing. Found our term numbers, how many terms we had, all that good stuff. So today we're going to talk about geometric sequences and series. There's two parts to this. We're going to talk about the beginning part, which is pretty straightforward and basic. Monday, we're going to finish up and figure out how to write a rule given two random terms, not the first one, but two that are kind of in the middle of your sequence. And we're going to talk about finding sums, partial sums of infinite and of finite. So it's two little different formulas. They're anything crazy, but I just didn't want to do it all at one time. So the first thing with geometric sequences, instead of finding the common difference, you find something called the common ratio, right? So in arithmetic, we find our common difference, what is being added or subtracted each time. In geometric, you find the common ratio, and this is what's being multiplied every time. We don't ever say multiplied or divided. If I want to multiply a number and make it smaller, what do I multiply by? A fraction. Very good. So if you see that something goes from like 12 to 6 to 3, you're not dividing by 2, you're multiplying by what? By a fraction, which would be 1/2, okay? So in order to find the ratio, a lot of times with adding and subtracting, it's pretty evident. You guys can look at it and say, okay, I added 17 each time. I subtracted 4. Sometimes with multiplication, it's a little harder because the numbers, especially if they're fractions, can be a little more difficult to compute in your brain, in your mind. So the easiest way to find the common ratio is to divide. You want to divide, D-I-V-I-D-E, the second term by the first term. You can do the third term by the second term. You can do the fifth term by the fourth term, whatever. But you want to take one term and divide it by the one before it. That will work every time to find your common ratio. Now, guys, if they give you a sequence and they say, is this arithmetic? You have to add or subtract the same thing every time. If they give you a sequence and say, is this geometric? It has to be multiplied every single time the same. If it's none of those, then it's neither. On your test, you're not going to be given anything that's not one or the other. We won't give you any neithers because we're not trying to confuse too much. But if you notice here, so you have these terms. On your questions on your test, they're not going to say, given the geometric or given the arithmetic. You guys have to figure that out. So the first thing you do when you have a series of numbers is figure out, are we multiplying to get to the next number, or are we adding or subtracting? So the first thing I would do to check is I would say, okay, from 2 to 4, I added 2, right? From 4 to 8, I added 4. From 8 to 16, I added 8. Am I adding or subtracting the same thing every time? No, so this is definitely not arithmetic. So now we need to figure out, well, wait, maybe it's geometric. So some of us can look at this and say, well, 2 times 2 gives me 4, right? And 4 times 2 gives me 8. And 8 times 2 gives me 16. All right, that's pretty apparent here. But again, as we get to numbers that are either a little bigger or when they're smaller, sometimes it's just easier to take the second term, which is 4, divide it by the first, which is 2, and you get 2. That'll work with any of the terms. You can take 16 and divide it by 8 and get what? 2. So here your common ratio would be 2. Does that make sense? Okay, like here, 12 to 36 to 108. You can see very quickly that you are not adding the same number to go from 12 to 36 to 108. But as the numbers get bigger, like I said, sometimes it's not as evident to see. So you can just take one of the terms. You could take 108 and divide it by what? What would I divide it by? 36. And what's that going to give me? 3. You can take 36 divided by 12, you get 3. So your common ratio in this sequence is 3. Does that make sense? So remember, geometric is multiplying. All right, and then we come to everyone's favorite, fractions. All right, this is where it's kind of hard. You guys are like, oh, I hate fractions. Okay, that's all right. They're never going to go away, so let's pay attention. If you take the second term, which is 1/9, everybody with me? Yeah. And divide it by the first term, which is what? -1/3. How do we divide fractions, guys? You keep change flip. So 1/9 times -3/1, right? So when I simplify this, it becomes -3/9, which is -1/3. What I want y'all to notice from this, which is important, what happens when your common ratio is negative? Look at your sequence. Look at your signs. Negative, then what? Then negative, then negative. They're going to alternate. Whenever your common ratio is negative, because think about it, if you multiply a positive number times a negative, you get negative. Then a negative times a negative is a positive. So when you have a negative common ratio, you should notice that your signs will alternate. So that's a good thing to look for. When you get a sequence of numbers and you see that the numbers alternate from signs, you can go, oh, that's probably geometric, and it's probably a negative common ratio. Does that make sense? Okay, good job, guys. Good job for Friday. So, yesterday we talked about arithmetic, and our arithmetic rule to find our nth term was a sub 1 plus n minus 1 times the common difference, right? That was our arithmetic. Okay, we were fine with that. We used that a whole bunch. To find the 12th term, you find your arithmetic rule, then plug in 12. To find the 15th term, you find your arithmetic rule, plug in 15, right? So in this case, we're going to find our geometric rule. God bless you. The formula is super easy. To find a geometric rule, it's a sub 1. You take the first term, you times it by the common ratio, and you raise it to the n minus 1 power. So if you're looking for the 5th term, where would you plug in 5? To the n. So it'd be 5 minus 1. So you'd be raising it to the 4th power in a sense. It's always going to be n minus 1. Always, always, always. So let's do an example here. Write the first 5 terms of the geometric sequence whose first term is 3 and whose common ratio is 2. So my rule, I'm going to write the rule. My rule is a1 times r to the n minus 1 power. So I have my first term is 3. I'm going to times that by 2 to the n minus 1. Guys, please notice this is 3 times 2 to the n minus 1. Is that 6 to the n minus 1? No. When you evaluate this, you have to evaluate the exponent first, then multiply by 3. So part of your answer is right here that you wrote your rule. And now how do I find the first 5 terms? You're going to plug in 1, 2, 3, 4, 5. So A1, A2, A3, A4, and A5. And the way you would show me that is just like this. You'd say 3 times 2 to the what? 1 minus 1. 3 times 2 to the 2 minus 1. 3 times 2 to the 3 minus 1. 3 times 2 to the 4 minus 1. And 3 times 2 to the 5 minus 1. So as we evaluate this, guys, what is 1 minus 1? This is 0. So I have 2 to the 0 power. 2 to the 0 power gives me 1. And 1 times 3 is 3. So then 2 minus 1, this is 1. So I have 2 to the first power is 2. And 2 times 3 is 6. Good. So now you have 3 minus 1 is 2. So I have 2 to the second power. And 4 times 3 is? Good. So then I have 4 to the third power. What's 2 to the third power? 8, good. And 8 times 3 is 24. And then I have 5 minus 1 is 4. So 2 to the 4th power, 16, right? Times 3 is 48. So the first 5 terms are 3, 6, 12, 24, and 48. Everybody see that? Okay. Pretty basic, right? Nothing crazy. All right, let's go to the next one. I'll leave 2 more examples, and then we'll be done. I'll let you guys work on your WebAssigns. You can do 8.2. You can start 8.3. We'll finish up 8.3 on Monday. So it says, find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.5, all right? I don't have a sequence of numbers, but I do have 2 pieces of very important information. I know that the first term, a sub 1, is 20, right? And what is my r? 1.05. Everybody see that? So I'm going to write my rule. I'm going to go ahead and write my rule. It's a sub n equals first term, which is 20, times 1.05 to the n minus 1 power, correct? What term are they asking me to find? The 15th. So I'm just going to say a sub 15, and I'm going to plug in 15 where? For the n. So I have 20 times 1.05 to the 15 minus 1 power. Now, I don't expect you guys to do that by hand, but I do expect to see this, and then you can use your calculator because I need to see that you know what you're doing. If all you guys do is just plug in numbers and write answers, you're not getting full credit. You have to show me your work. So you would answer this as a sub 15. So the 15th term is, what's 20 times 1.05 to the 14th power? You have to do 1.05 to the 14th power and then multiply it by 20. What do you guys get? 39 point what? 59. You guys agree? Okay, something like that. Everybody okay? Okay. Questions? No? All right, let's look at the last one then. Find the formula for the nth term of the following geometric. What is the 9th term of the sequence? Okay, so we have 2 questions here. It says find the formula. Now, on your test, it may just say something like this. Find the formula for the sequence, right? We're not giving you formulas or anything like that. You need to know that. But this doesn't tell me if it's geometric or if it's arithmetic. So you have to go, okay, how'd I get from 5 to 15? Well, I added 10. How'd I get from 15 to 45? Well, I added 20. Is this arithmetic? No. So then we'll go, okay, well then let's figure this out. Again, you could do this 2 ways. You could say, how did I get from 5 to 15? I multiplied by 3. How did I get from 15 to 45? I multiplied by 3, correct? Another way you could do it is r equals, take one term and divide it by the 1 in front of it. So 15 divided by 5 equals 3. 45 divided by 15 equals 3. So you have the information you need. A sub 1, your first term is 5. Your common ratio is 3. So now we can write our rule. A sub n, whatever number we're going to look for in the future, is our first term, which is 5, times r to the n minus 1. So that was the first part of the question, is to write the formula. Then the second thing says, what is the 9th term? So I'm going to say, okay, if I want to find the 9th term, I'm going to plug in 9 for my n, correct? So 5 times 3 to the 9 minus 1, which is really what? The 8th, okay? So in your calculators, you guys need to evaluate this first. It's not 5 times 15, or 5 times 3 to the 8th power. It's 3 to the 8th, and then we multiply that by 5. So what is the 9th term of this geometric sequence? 32,805. What do you guys notice about the answers, not the answers, but the numbers in a sequence for geometric versus arithmetic? They get a lot bigger, a lot faster, right? Because instead of adding or subtracting every time, you're multiplying. So your numbers are going to get bigger in a hurry and they're going to get smaller in a hurry. Does that make sense?
Yes.
Everybody okay? Yes. All right, that's all I want to do for now. On Monday, we're going to do a problem that gives you like the 4th term and the 10th term. And you have to write the sequence. You got to write the rule and then find a term. Okay, when it's arithmetic, it's pretty simple. We did that yesterday. It's a little more difficult when we have a geometric. And then we're going to find the sum of finite and infinite. And it's not hard. There's 2 formulas. It's very simple. But the hardest part is the geometric when you're trying to find the rule given like the 4th term and the 10th term. So, all right, so you guys have time now. If you would like to work on your homework and ask any questions, feel free.